typically all appliances in the last 20, 30 years or so are tested anyway on a blend of 20% before they're put on the market. So the boiler I've got in my house, that can take a 20% hydrogen blend.
Do you think there's a challenge associated with how led by industry the sector is?
The costs of repurposing part of the system to operate for hydrogen alongside existing system for natural gas is a lower cost solution than building an entirely new core hydrogen backbone. I think within the next year we should get our first 5 minutes, half an hour maybe, of zero carbon electricity on the system, enabled by new technologies being developed on the electricity system.
Oliver, hi. Thank you for joining me today.
No problem at all.
So why don't we get started by having a quick introduction to yourself and the work that you do at iGEM?
Yeah, sure. My name is Oliver Lancaster. I'm the Chief Executive at iGEM. That's the Institution of Gas Engineers and Managers. So we are the professional engineering institution for the gas sector and the emerging hydrogen sector in the UK and overseas as well. We have thousands of individual members, a lot of which are engineers, but it's not solely engineers. And we also have company members as well as a network of organisations involved in the sector. And there's about 420 of those who are gathered under iGEM.
From that introduction that you've just given and the conversations that you have on a daily basis and the sort of your perspective of the industry, I imagine that you might be a good person for me to quiz on the energy sector. Why don't we start with what does today's energy system look like?
You know, I do try to make sure I've got a balanced view across all forms of energy, and iGEM is seeking to engineer a sustainable gas future. So we've got to work out what our place is across the whole energy system. And it's right to step back probably and think about what the whole energy system actually is, because we quite often might just look at one small corner of it, or we might neglect parts of it that we're unfamiliar with. And so taking some time to wrap our arms around it is a good thing to do. And so I'd say the energy system of today is pretty vast. And like in school workshops and things, you can ask them, what is the energy system? And it's quite interesting to see what the answers are that come out. But I'd say it's from one end to the other. So at one end, you've got homes and you've got radiators, pipe work, some hot water cylinders, different levels of insulation, different technologies in the home using energy for heating, for powering things like appliances, for your oven and things like that. And then you've got the whole network infrastructure, the pipes and the wires that move the molecules and the electrons around. And then the opposite end of it, you've got where that energy kind of starts. So the turbine blades in offshore wind, for example, where gas is produced or where hydrogen might be made or biomethane made. And then also the complicating factor of international connections, the interconnectors that tap into other markets and production and generation as well. And so everything hangs off all of those. It's quite a vast system, and we've got to be careful. If we kick one part of it, you need to look out for whether other things will fall off somewhere else. And so it's a carefully balanced system that we need to be working on a transition for.
And as you say, it's quite it's a very interconnected, somewhat complex energy system. I guess the scale of infrastructure, the scale of distribution, etc., is determined by the demand profile. If we think about some of the big themes within the energy sector at the minute, you've got the shift towards renewable energy, so the energy transition. You've got the exploration of lower carbon fuels such as hydrogen. You've got the influx of CO2 as a potential opportunity as well. From your perspective, what does demand profile look like? And what does the distribution look like across the consumer energy demand versus sort of industry?
Yeah. In history, if you're looking back like a couple of 100 years, energy supply and demand was all very much local. It tends to be what we hear about today, local area energy planning. It was developed locally, and you've got probably what you would now call bundled services for gas, electricity, water, to all the different kinds of customers that you would have. And then it became very national. There's a challenge to try and tackle what the right balance is for the energy system across those different demands placed all across the system and where the production or generation might be. The demands can often get siloed in thinking about how we might decarbonize. Quite often you'll hear about what industry might do. Quite often commercial gets left out of it. There's a lot of those connections. And then homes, of course, and then what might be happening in the transport sector as well. But the biggest thing that I mentioned first, and you referred to it in industry, is that it's usually assumed to be conveniently clustered in the coast, like around ports. Decarbonisation of industry is something that can happen in those areas as a focused, concentrated effort. But actually, industry is distributed everywhere. The different demands all share the same pipe. Industry, commercial, flexible power generation, and homes, and some transport connections. They all share the same pipe. So if we're talking about doing one thing for one, then we need to be thinking about what impact that has on other demands. So if a certain distributed industry that can't electrify, that needs hydrogen for its future, needs a supply from a pipeline system, but the pipeline system is also delivering for homes and flexible power generation, then it's obviously a more complicated planning piece and conversation to have. What policies are going to help support that change, rather than it being that overly simplified, well, that pipe delivers to industry, that pipe delivers to flexible power, that pipe delivers to homes. It's a complex piece.
What you've just described there, it must be quite a difficult task from a planning perspective. How can the industry be efficient with the planning for what you've just described when there are so many different moving parts?
Yeah, it's really difficult because corporates, businesses, organizations, they want to all move quickly, and quite often they want to move first, and for whatever it is that they make to be a greener product. And there's common sense behind large consumers, large industrial consumers that are located relatively close to each other, that you see the beginnings of hydrogen production, storage and transportation to meet the needs of those consumers, because some of them are there together. But that kind of sets back the ambition of those industries that are more distributed. There's 67,000 industrial connections to the gas grid, and all but maybe a couple of hundred of them are in the below 7 bar pressure network. That's the equivalent to the electricity systems, like lower voltage end. It makes you wonder about how we might really begin to tackle this. There's that initial infrastructure needed, and that's happening. I mean, for hydrogen, that's happening with business models that are coming out of government for production, which the first round have been awarded, and next coming quicker than initially it seemed behind it are the business models for storage and transportation, so that you begin to make those connections and overcome that chicken and egg situation of having people who want to make hydrogen, people who want to consume it, but having them growing at the right pace and at the same time to meet their needs. So there's that initial more local and regional core infrastructure that's needed to get things moving. But there is the demand there. There's probably 100 organizations that I've seen that are waiting for a supply of hydrogen.
Do you think there's a challenge associated with how led by industry the sector is? Or do you think that that is actually a way to accelerate the growth of new forms of energy?
I think it's quite helpful. I think because new technologies and new energy vectors need to grow significantly and at scale, that's helped a lot by the fact that you can do relatively small geography infrastructure projects to deal with some significant demand and production to get that started. So I think it's quite helpful that opportunity is there, but it's not just industry. In fact, I think power generation is probably slightly ahead in the priority list, because all political parties largely seem to be aligned in having a net zero power system target, albeit current targets are just a few years apart on when the ambition is to deliver that. But quite often you'll find that those large power stations and some of the smaller flexible gas engine power stations. There's quite a few of those located in and around the areas where you've got that clustered industry. And so if you can be meeting the needs of power generation, some of that might be carbon capture, post-combustion carbon capture. Some of those might be converting to hydrogen, particularly if they're within reasonable striking distance of where there might be large-scale hydrogen production and other industry around. Then that's going to help to determine what that kind of minimum viable product beginnings of hydrogen transportation infrastructure looks like to meet those demands. But that infrastructure isn't laid in a way which closes off other demands and wider demands connecting in to use that route of bringing hydrogen into a network for different demands to use. So rather than trying to save a few pence on laying some new pipelines just to have the capacity for what the first demands are going to be, then the marginal increase in the cost of laying that pipe, so you've got a large demand capacity available, a ceiling of capacity available from that pioneering pipeline, it then opens the opportunity for others to connect in and use. And the same applies to electricity. If you're going to be putting new cables strung across to increase the capacity between generation and demand, then let's make sure we put the capacity in there so we don't have to keep going back doing things again and again, which ends up costing more money capital wise, and it ends up being more money that has to be paid for on people's bills.
Yeah. And a couple of the points you've just mentioned there. So the net zero 2050 target, you also spoke about adding capacity to the existing network. I want to just, for total clarity, ask what are the reasons for this scale of investment needed? What specific challenges are we trying to solve with the exploration of these new capabilities and technologies and the scale of infrastructure that we're putting into the ground?
First of all, we want to make use of what existing infrastructure we have. And if we've got capacity headroom in there, then let's use that as far as electricity is concerned. If, for example, I had a heat pump paired with my boiler and I have a capacity of connection to the electricity distribution network, I'd be able to set my heat pump to be able to use whatever capacity and headroom is available in that connection at any one time to give some efficient heat from that. So making best use of the capacity we have is important. And then we're going to need more capacities of everything to be able to shift away from reliance on fossil fuels to be able to use energy that's net zero. That is getting electrons from where it's generated to where the demand is. That could be through wires or in part through turning that electricity into molecules and shifting it through pipelines. And then the same with the gas system, making use of what we have. A large portion of the existing gas system can be repurposed to transport hydrogen. But in some of the earlier days, there's going to need to be some degree of new pipelines to be able to operate both natural gas and hydrogen, and to be able to back out natural gas from areas if there is some reasonable degree of hydrogen conversion of the gas grid, so that you're able to slowly back it out of an area. So you need to be able to have both of them as a supply. And some areas already have multiple routes of gas to get into a city, for example. And so you've already got a lot of the pipe work there to be able to transform. But if you only got a single feed, then you've got to think of other ways. And so in some instances, for example, the South Wales Industrial Cluster, there's a project called High Line, and that's to get an initial piece of pipe work across a chunk of the South Wales coast between where it is expected there'll be hydrogen production to then deliver for some different industrial and power generation customers. And from then, you then have that initial infrastructure to begin repurposing what's already there. And the same applies in mainland Europe as well. When it comes to hydrogen, the European hydrogen backbone, that's assessed what proportion can be repurposed and what proportion of new pipelines are needed to enable the repurposing and to enable further distribution of hydrogen. So it's a lot of work to work out exactly what's needed, but a lot of that's been in progress for a few years now.
And what would you say have been the sort of key learnings from the progress that we've made over the last couple of years?
There's been some assessment, for example, in looking at the gas transmission system in the UK and what could be repurposed, and looking at the network insofar as what can be repurposed to provide the needs for moving hydrogen around between the main industrial clusters, and then what the rest of the system can still do to meet our demands for natural gas today. And then how that compares against having a brand new hydrogen transmission system. Thus far, I understand the costs of repurposing part of the system to operate for hydrogen alongside existing system for natural gas is a lower cost solution than building an entirely new core hydrogen backbone. But that's not complete yet. But the learnings are showing us that that's the right thing to do.
Did we initially to go through that process where we did make a level of investment into new pipes to be able to then compare to the repurposing option? I guess we had to go through that process of testing it out and learning to then determine what the optimal process
Yeah,
is.
and there's other aspects to it as well. For example, if you build a brand new network, you would have a shorter network to maintain. You would probably have a whole bunch of brand new compressors that are all the same, that are nice to be operating the same ones and maintaining the same ones. Conversely, a bit of an issue with this is that you would have so many landowners to be able to agree easements with on taking that new pipeline through areas that haven't had a pipeline before. Whereas if you're repurposing, you're working with your existing asset in the ground, your existing easement. And that's a little bit like the planning matter for getting connections to the electricity grid. If you can avoid that problem, which can stack up legal matters for a long time on getting those agreed, if you can avoid that and use what's already in the ground, then all the better for getting some action done more quickly.
On the CO2 side of things, the carbon capture world is hot and has been for quite a while now. And there is so much venture capital flowing into the industry, so many different types of capture, storage methods. Role of distribution is a key dependency. And I know that there has been a fair level of investment made into the world of CO2
Mm.
distribution. Where is that market at the minute? And are there any learnings from that? Because I imagine it's quite a new technology in a way.
Yeah, I'd say before net zero, when it was an 80% target, there was a lot more going on insofar as the potential network of carbon dioxide and where those pipelines might be, initially connecting up to the largest emitters to be able to then perhaps connect in more emitters that are like lower end emitters over time, and having something that looks a bit like the gas grid, albeit for kind of industry and power, really. But then zero came along, and hydrogen then became a lot more important because you need to minimize the emissions as far as possible. And then any emissions you've got left over have negative emissions to balance for that net zero. It became more of a distribute net zero gas to those who need it and have what amount of carbon capture is needed in shorter portions, smaller portions. So, for example, yeah, we're hoping there's going to be a lot of green hydrogen produced from renewables with electrolysis. And there seems to be some promising work ongoing with regards to natural hydrogen as well, but that's in the longer grass. But blue hydrogen production from reforming natural gas, if you can do that to help the scaling of the hydrogen sector quickly, if you can do that in these concentrated areas where your natural gas comes in at the coast, wherever that might be, then all you need there is a kind of a short pipeline to export it, either to export it out to sea for storage or to export it to shipping that can go and then sail around and take advantage of the areas where you can then deposit it for a gate fee. But it's gone from being something that's potentially a significant network to being in my opinion, something that's relatively small and localized around where you've got major emitters. And that could be post-combustion carbon capture from power stations and hydrogen production. In the north of England, in the northeast, there may be a reasonable stretch of carbon dioxide pipeline that's been designed to meet all the way into where Drax power station is in North Yorkshire. So there may be some exceptions where there's some reasonable length of pipe, but it was something I had a significant interest in, but now in the whole pipeline network world, it's a little bit smaller than was initially anticipated, but it's significant enough anyway to get right for those areas of hydrogen production and post-combustion capture from power stations.
I imagine from an industry development perspective and attracting foreign investments, that might make it quite a challenging environment because of how changing it is and how determined by policy and also industrial preferences.
So I think the opportunity has shrunk for carbon dioxide pipeline networks, and it's probably shrunk insofar as retrofitting post-combustion carbon capture to lots of different industries is concerned. But as far as what I'd see as being the more key parts of it being the depositing, being the long-term storage sites, forever storage sites, and the onshore infrastructure to be able to get that to the storage sites, and for there to be shipping from locations with industry that doesn't have the benefit of those nearby storage sites. All that is still as important and exciting and needing of investment and with opportunity as it was before. It's just, as I say, I think that the network length has shrunk. The opportunity for retrofitting carbon capture and storage, carbon capture on industry has shrunk as well. I'll use an example. I don't know whether I'm allowed to say who it is, but so I won't. When we look at distributed industry, there's one example that would like to decarbonize its operations. It can't electrify, but it could have carbon capture that needs a carbon dioxide pipeline, or it could convert to hydrogen. But to retrofit carbon capture to the site, they would have to double the footprint to build the carbon capture part of it. And there is not the land surrounding this site to be able to increase capacity. So its only option is hydrogen, and it needs to arrive by pipeline because they just wouldn't be able to have an islanded production and storage operation on the site. And they're not interested in having islanded production, storage, and on-site distribution. Don't know if that helped.
Yeah, it does, because it gives a good indication of almost like the pros and cons of CO2 versus hydrogen. I guess sticking with the example, what would you say are the other deciding factors between retrofitting carbon capture versus converting to hydrogen power as a means of decarboning?
I think if you have retrofitted carbon capture to industry all over the place, you'll have less efficient capture of carbon from the system. If you concentrated your carbon capture at the point of producing hydrogen with the most modern methane reformers, people often will say about steam methane reformation, but it's moved on a few levels of technology since then, with about 97% capture as a minimum. And so if you've got that level of efficiency in capture and flexibility in production rates as well, then you're going to be able to save much more carbon dioxide than if you were to apply the retrofitted carbon capture, which would not capture as much overall. So you're saving carbon by concentrating on where you capture it strategically, where you're producing the hydrogen, rather than capturing it all over the place at different industrial locations.
I'm sure you get asked this a lot around, okay, should I, as big industry, shift my facilities over to hydrogen? What would you say is the general position or the perspective on hydrogen around the opportunity?
Yeah, so it depends what the industry is and what their needs are for heat and power, and what temperature they require for their process particularly. And then there's a question around, can they feasibly electrify in which case try and get to the bottom of how much that would cost and when you can do it. And then there's those in the basket where they need the molecule, they need molecular energy delivered to them because of the temperatures they need, or the amount of energy they need for their process. And then there's the middle ground where theoretically you could electrify the process. However, the capital costs of retrofitting or replacing the factory, large parts of the industrial site, are cost prohibitive for changing over. But also I know that some industrial locations would like to electrify or partly electrify, but they're not able to because of the prohibitive costs of upgrade of the electricity infrastructure to be able to give them the capacity that they need. So there's a whole range of different things that come into play with regards to whether industry can do something now or not. But they typically can't have a hydrogen supply right now, today. And so that's where a lot of industry, they've been testing their plant on hydrogen, doing short tests of making bricks, tiles, biscuits, even glass, all kinds of stuff, and proving what they can do with their existing assets, identifying what changes there might need to be to accommodate it. But they're all raising the keen interest in being able to receive hydrogen supply. But that's all work in progress at the moment.
But just for clarity, hydrogen isn't currently available at that sort of industrial scale that is required for a big industry player. What are the sort of timelines associated with that?
For big industry, they would typically need a lot more than you could accommodate by having a delivery of hydrogen on a trailer connected into a facility, or to have your own production set up. As far as the timeframes are concerned, if decisions are made quickly, policy-wise, tend not to be all that quick, but the core transmission infrastructure and setting aside part of the gas transmission system for hydrogen to connect up the main clusters, that, with a fair wind, and as I say, quick policy decisions, could be up and running in the early 2030s, sub 10 years. And then with a fair wind in policy making, decision making, and allowance of investment ahead of need in the gas sector, as agile as it can possibly be, then there's no reason why in that same time frame you can't be seeing the initial connections of production of hydrogen to consumers of hydrogen, so that those first large consumers of it can be receiving a supply before the end of this decade, 2027, 28 maybe. And that's when you will see, with that transmission system balancing hydrogen between supply and demand across all the clusters, and the local transmission and distribution that grows as well with those initial connections. That just provides the base infrastructure to then begin to connect more and more onto them. And as I said before, that marginal cost of having that larger ceiling of capacity at first enables more to come on and take a supply of that as well.
You referred to at the start this idea of a national, regional, and local thought process to hydrogen. Would you mind shedding a little bit of light on the relationship between where industry is located and what kind of effect or relationship that would have with the availability of hydrogen?
Yeah, so if I take, first of all, where industry is, so if there's a few hundred industrial connections to local and national transmission system, which are very thirsty connections, the vast majority are on distribution. And I've heard it been said not long ago that for distributed industry that can't electrify, they'll just have to move. And they're not going to do that. They're certainly not easily going to do that. And if they move, they might as well actually move offshore and take their business elsewhere. And the problem that creates is that where you've got all this distributed industry, you'll just create a vacuum of industry and work and have jobs issues and local economic decimation. There's a risk that if we don't do this right, then the consequences are significant. So it has to be done right. And there is a local, national and regional in the middle aspect to this. But there needs to be a plan for all. Otherwise, it doesn't work as a whole piece. When it comes to hydrogen, then I said before about it's important to be building the scale of it very quickly. And the scale comes where you've got that clustering of initial off-takers, the initial demand from power and industry, where they're clustered together, and then a build out of the networks from there. And you can have conversion planning for networks from there, so that there's a period of a few years of readiness where industry can be getting ready, preparing for their gas to change over. But as far as hydrogen production goes, it is easier if it strategically comes in at points of higher pressure on the system and is fed down from there. I know that people have been raising queries about, can I put hydrogen in here? Can I put hydrogen in there? Because I've got this local electricity generation and I've got constraints and I could do with using it. Can I make hydrogen and put it in your network or this network or that network? And that's where we come down to blending. And the problem with doing it to all these little locations is it becomes quite difficult to manage a 20% by volume hydrogen blending limit if it's coming from different places, and then having to monitor that and maybe close the valves of different producers putting hydrogen into the network. That would be a really complex way of managing it. But the easy way of managing it is if at the top end of the system, top end of distribution or up in transmission, you've got blending coming in there at scale, and you can manage the blending limits at the point of entry to the lower pressure system.
And Oliver, sorry, just on the point of
Yep.
blending, would you mind actually just breaking down what we mean by blending exactly?
Yeah, there's been a project that's been going on for a long time called High Deploy, different phases of it, looking at how we might go about blending hydrogen into the natural gas system, 20% by volume blend, which by energy density is a 6 to 7% blend. And therefore, if it's clean hydrogen coming into the system, low carbon hydrogen coming into the system, it's a 6 to 7% carbon reduction. And so that's been tested on a private network, Keele University, delivering to different buildings, including about 100 homes, and testing how the different appliances cope with a hydrogen blend. Typically, all appliances in the last 20, 30 years or so are tested anyway on a blend of 20% before they're put on the market. So the boiler I've got in my house is actually quite old. It's about 20 years old. That can take a 20% hydrogen blend. There's a kind of natural limit on what can be put in the system. Industry has been tested on this as well. Some of them may be a little bit more sensitive. Some of them might have to buffer the blend so that it's more steady in case it's a little bit up and down. Or they may have some sensitivities around a piece of plant that can only operate on a 10% blend, in which case they might have to deblend a little bit from the system for their site. So blending has been tested to the point where government can make a decision on it. And last December, they made a decision to allow hydrogen blending as an off-taker of last resort. So that's where hydrogen can be put into the distribution network if there is surplus hydrogen produced as somewhere for it to go, rather than be wasted or needing to overbuild storage for hydrogen. But it doesn't currently allow for blending to be a strategic off-taker, which is a bit of a blocker for industry wanting to decarbonise. So all those like 100 or so industries where we'd recognise supermarket shelf labels, logos and things like that, they all want hydrogen blending because they'll then be able to procure the hydrogen to help decarbonise their operations. But without it being a strategic off-taker, that can't happen.
And I guess the idea behind blending is to ease them into their hydrogen journey. And it means that they don't have to significantly retrofit or upgrade their infrastructure to take a pure hydrogen intake. It, like you say, they can use their existing gas network and it allows them to decarbonize whilst not having a high capex.
Yeah, it's largely something they can do without having to change a great deal. And they can also buy more hydrogen that's produced than they use as a way of accommodating for more of their emissions from their site. But yeah, it has been tested to 20% in a lot of industries, anticipating and hoping that they're going to be able to receive that And all the while, they make plans and preparations and what their capital investment plan would be normally for their operations and how they might time replacement of assets for when they would normally replace them so that they become hydrogen ready, 100% hydrogen ready without much of a cost penalty. But if a particular industry was going to be a blocker for 100% hydrogen coming to a certain part of a city because they couldn't accommodate 100% hydrogen yet, then that's a case where perhaps there needs to be grant support for some industries to get them over the line sooner so that they're not stopping the rest of a network area being able to convert over.
And on the point around blending, obviously you spoke there about the demand side. What impact does the demand for blending have on the producer side and the generation side?
It helps the hydrogen producers in having another consumer of hydrogen there for them. So it improves their economic case in building a production and storage plant with some initial distribution to specific customers taking 100% supply. But being able to have the opportunity of blending up to 20% allowed for within their strategic planning of capacities and investment for that opens up their opportunities further and doesn't constrain them as it currently does.
Oliver, just one last question to finish. What are your predictions for the energy system looking ahead to the next 12, 24 months, even beyond that, to maybe 2030 or so? Where do you see the biggest change coming in that we should expect?
Golly, they're usually all wrong predictions, aren't they? But in the relatively near term, I would like to think that the zero carbon power system target is achieved. I think 2030 is rather challenging. With enough ambition, effort and investment thrown at it, then you at least give it a fair shout. But I think within the next year, we should get our first 5 minutes, half an hour, maybe, of zero carbon electricity on the system, enabled by new technologies being developed on the electricity system. That means you don't have to have fossil fuel system, a gas turbine or gas engines only being on to have a stable electricity grid, which is sometimes what you'll see today, some low levels of gas-fired power, even on the windiest days, because it's needed for stable electricity grid. So that should be coming in the next year or so. I think there's justification for building out a lot of different capacities of different technologies to begin learning what works and what doesn't, and then investors learning and moving on with what they can see having a role to play. I don't think there's a great deal of regret in building any capacity anything in the next 5 to 10 years or so. We should just get on with it and accept that there will be some low regrets. We're not going to be in a situation of no regrets. If we are, then we're just prioritizing perfection rather than pragmatically moving forward. As far as what we might see in homes, I think heat pumps have been going in, but certainly not at the rate that the government have set as a target. I've been way off that. It would be useful to have the mandating of hydrogen-ready boilers there, so that in the event that areas convert over, then it's a limited conversion kit for them to move over their boiler. And because they come at no additional cost to the consumer, then why wouldn't you do that? But I think the interesting movement might be in the role of hybrid heating systems. So being able to take a heat pump that works intelligently with a boiler that takes control signals from the wider energy system, so that helping to deliver least cost heat for the home, least cost comfort for the home, but also is trying to balance for lowest total system carbon as well, and helps to make use of the electricity system so that you have to wait for the capacity to increase to accommodate a heat pump and heating system. It can work within the existing capacity constraint that there might be. So I think the emergence of hybrids maybe in the boiler upgrade scheme being something to look out for, as well as next generation boilers that are hydrogen ready. But to see.
Stay tuned. Oliver, thank you so much for your time today. I really appreciate it.
No problem at all. Good to chat.